Thank you. So what I wanted to talk to you about today was my experience in designing and creating a full motion, fully enclosed simulator. And the reasoning for that was that I wanted to look at it more from a kind of somewhat physiological, psychological basis, in the sense that when you're flying a real-world airplane, you're relying on all the senses that are coming into you from vision, from hearing, from feeling, forces and vibration and so forth. So I thought, how can I create such an environment that more closely simulates that real-world experience? So a little quick background just about myself so you have some idea where I'm coming from. I've been flying for too long, I guess, but anyway, I got my private in 1968. And I went on to get private multi-engine rating and so forth. So I have about 2,000 hours of flight at this point in time. And I've flown everything from a Piper Tri-Pacer to a Beechcraft King Air. I don't have any special extra type ratings beyond that, but not important. Anyway, my absolute favorite airplane is the Helio Courier, which I don't know if any of you know about it, but it's a STOL airplane, short takeoff and landing. So by NATO standards, you can fly this over a 50-foot tree, come down and land with another 50-foot tree 600 feet away. So it has a landing roll of about 200 feet. So, and the instrument panel on it was, I owned this for about 10 years or so, but it was one of the first GPS moving maps is over, sorry, I've got it, sorry about that. Let me go back. There. This is a GPS moving map, monocolor, and you could actually see, you know, VORs and do basic instrument flying. And this one over here is looks at electrical activity instead of raindrops, so it substitutes for radar for weather. So anyway, when I had this, I wanted to try to get the latest of things, and that was my example of that. So my day job is I'm a practicing physician, and I've always been interested, of course, in aviation and medicine together. So I worked a little while for the FAA in Oklahoma City at the CAMI, the Civil Aeromedical Institute, that investigated how do you design aircraft to minimize injuries and death upon crashing. And so that was like an engineering situation. At any rate, so why am I here? I discovered simulators, do-it-yourself simulators from the Las Vegas 2018 Las Vegas seminars. And so with this, I was looking around to see what is available off the shelf that I could make my own simulator. And originally it was just for IFR, for training, for procedural stuff. But then I got kind of hooked with it and found out that I really wanted to do is I wanted to make a simulator that was much more all-encompassing, or immersive, I should say. Whereas the desktop and the tabletops and so forth and various screens was great for what they are, but I decided I wanted to make it even closer to the real-world experience. I also wanted to be able to do that by assembling it and reassembling it in a typical bedroom or den or something, which most of the large, the larger full cockpits, fully enclosed cockpits, won't fit through a door. So I wanted to make it so it would fit through a door. Anyway, so the approach I had was, how do you manipulate perception to get that real world experience is really what I'm after. So these are the different, oops, I keep hitting the wrong button. Hold on. So these are the different senses that we really use when you're flying to know that you're really flying an actual airplane. So vision, of course, is critical, is important, but so is hearing, the sound you feel, balance, and the vibration sense, the sense of feeling the engine, the wheels touching down, all that kind of thing. Pressure sensors, of course, for how much force are you exerting on the control devices, with a yoke or a rudder or whatever it might be. That's really a key part, because as you know, a lot of flying, besides the instruments and the procedures, is to really feel the airplane. The airplane becomes part of you in a sense, and you can do that because of these different senses. And so how do you manipulate that to make it a real experience? So there we go. So that's pretty much, yeah, we'll go to the next one. So in the vision sense, the most common thing to do would be to have a system where you have 2 or 3 or a number of monitors. But the problem I had with that was just that, for me, the border of the monitors kind of, with everything else around you, sort of got in the way of that feeling that you're really in a simulator. So I said, well, what are the different ways I can present the information? So this, for instance, is a projector system, which is a projector up here. And I thought I had to have the screen large enough so that when you're sitting in the pilot seat, you don't see the borders, because that was kind of important. And then also, I thought, well, if it's going to be in a bedroom, you don't have room to have a full projector system and all that, in terms of like 3 projectors and have a 180-degree sweep. So instead, I said, well, let's put side windows here on left and right, and that will kind of simulate it, and then you have to hook all of that together. This is what I ended up with, essentially, is this is a skeleton of the simulator itself. It's full-size Cessna 182 cockpit, as far as dimensions are concerned. And then I had a large screen. It turned out that LG recently has an 86-inch 4K screen. So that's what I've got in it now. And then the structure of it is Baltic birch, 1-inch. It's a very heavy, strong density plywood. And these are all CNC cut out. So all the parts are done based on SolidWorks design. And I'm familiar with SolidWorks, but SolidWorks gives you it's kind of a mechanical engineering tool. You can also do modeling, so you get all the stresses in real life of how strong the material is, when it fails, all that kind of thing. So this consists of 3 parts. So you have a rear, a middle, and a front part of it. These 3 are bolted together, so they all unbolt. And that way you can take these 3 pieces in the floor and the screen out a bedroom door or whatever. So this way you don't have to have a garage or something to do it. Let me just check on my time. Okay, not too bad. We got that. So let's go to this one. So this is an ideal system if you have the room. This is 3 projectors. You have to have special software to stitch all the images together so they all work. And this gives you 180 degrees, or could give you more. But in this system, and ALSim, for instance, has this system. It's a French company that has a fully enclosed, semi-fully enclosed cockpit. Is that theirs doesn't move, and one of the reasons it doesn't move is if you were moving, you would then see the black here, and you'd see this. So you have to pretty much have, I think, either very, very tall ceilings or have your image part of the cockpit in order for that to work. So that's that. So we'll go to vision now. The next is just a quick series of construction to show you how I actually built it. I built it so one person can build this, 95% of it anyway, without help. All the parts, as I said, are all CNC'd, all the holes are drilled, and so forth. So it starts out with the floor, goes with, these are all my CNC parts. They're all done there. And then I put casters on it. This is before I did the motion platform. And here's some of the parts, and they're all bolted together. This is an attachment I'm using in order to attach it to the floor. And you can see here how it's standing up. It's attached to that aluminum L bracket. And that's a couple of them together. And these are how the modules are actually formed. And there I am trying to put it together. I use a lot of clamps. I did this all just with no help, just one person, me. There it stands up. That's the rear, and here's the another module coming up, and this is the front part, which is going to be here. Kind of use clamps. I don't know if I'm going too fast. Is it right? And this is will be the front where the instrument panel will be. And here's the instrument panel, well, precursor of it. So I wanted to make it as flexible as possible. So in order to do that, I have one carrier here, and in this carrier I can put any shape, size, instrument panel I want in here. Size screen, whatever it is. I'll show you in a minute what I ended up with. But this then, here, when it's in place, which I'll show you in a minute, it can go up and down, and this is like an open slate that you can put whatever you want in it. And that for different height pilots and so forth, this accommodates that. Same thing for the side windows, they're adjustable also. And there it is in place. This is where I decided to go to with a touch screen, a 27-inch touch screen, and a full radio stack, which would be direct control. And then I'll go to the next one. And there's side view. And here we're putting this in and putting them all together. And then there's the floor. There's the aluminum plates that hold everything. And then here's the floor kind of upside down. And you'll see now I'm taking the floor here and putting it down. And there I'm sitting in my, this is my ex-Helio Courier seat, and so I put that slide in before. This is actually a Cessna Caravan seat that I got used, and I flew that seat in the Helio for 10 years because the seat was much better designed. It was a Part 23, which was crash worthy and all the rest of that. So anyway, going here, this is the carpet, and now you can see I've got full force, which I'll come to a little bit later, full force feedback ailerons, but yoke for aileron control and pitch. And then I'll also have full force feedback rudders. That is tied in with the elevator trim and so forth, which will be coming later. But here's my radio stack. Here's this. The important part about this, which I'll show in a minute, is that when you touch any instrument, the advantage of this, of course, is that by having a 27-inch touchscreen, I use X-plane as a basis. And so whatever you can fly an X-plane in this category of airplane, you can put in here. So this will allow me to fly 20 different airplanes, so to speak. But the nice part is that anything that you touch that turns or pushes, you touch it, and then you go over to this little knob over here. This is Knobster, some of you might be familiar with it. And you actually do the turning. So this way you have not just what you look at and what you touch, but you have the actual muscle memory, as they call it, of turning that knob. So let me get here. Here's where I put the skin on. The skin is a 60 thousandths polystyrene. It's nice because it's already white and it's already painted. I don't have to paint it or anything. And I have clamps and so forth to do. This is the one thing you need a helper with to get it aligned right. And then here it is with the skin all screwed in, everything's screwed in. They kind of look like rivets a little bit, so that's why I chose that. And then here I'm putting in the upholstery. See? And then here's my touch screen, and here's the Garmin 530 and the radio stack. And there, so that's pretty much the finished version, at least one picture of it, where I have really functional controls as far as throttle, pitch, and gear. A lot of the ones that are available now are very unrealistic in the sense that throttles normally have a certain friction to them. They have a friction lock. The prop and mixture controls are vernier and turning, so you can fine tune it and you push in and out. So these do all that, and a lot of them don't. So that seemed to make a difference to me, I think. And then over here I have a full switch panel for the ignition and lights and circuit breakers and so forth. And there's my Garmin 530 and usual panel of audio panel and Navcom and so forth and so on. Autopilot at the bottom, and there's this part. So let me get to that. Good. So For surround sound, again, on the theme of how much stimulus can I put into this, stimuli, so that you really feel like you're flying and not in a simulator. So I just used like a Logitech 5.1 surround sound, which is no big deal. But anyway, that's what I did with that. So we have, everybody has specialized sensors in their skin. And so this was just to show it's a little bit detailed. But anyway, there are two different sensors specifically that pick up vibration, that sense vibration. And that's kind of important if you want to simulate the vibration that we feel when we're flying a real airplane. So in order to get that, I use a butt kicker. I don't know if you're familiar with it or not, but it's an infrasonic generator. There's a piston here. It's about 5 pounds, and it goes up and down. And it's driven by a 1,000 watt power amplifier that you would get for a subwoofer or something in a customized truck or something. Anyway, and so this is the circuitry that you have to go through. So basically, I'm feeding the signals out of X-plane into this amplification system, and then putting it then directly into that butt kicker, which drives it. And it drives it exactly in time and synchronization with what you would expect to feel if you were touching down as a landing, running up, going on a taxiway. All those little feelings, not sound, but you get sound and feelings together, makes an incredibly different experience. Pressure sensors. Okay. So here's what I'm using for my force feedback. Let me just check my time again. Okay, doing good. This one, I think I've looked at a number of them. There's actually only 2 or 3 on the market that actually are commercialized. There's a bunch you can build yourself if you want to try that. This gives you not only a decent range of motion, which is about 6 inches or a little over 6 inches. A lot of the yokes are like 3 or 4 or something. But it gives you 22 Newton meters of force. So when you're feeling the yoke, if you're trying to pull out of a dive, or you're trying to climb, or whatever you're doing, it's much closer, not quite to the real one, but much closer than most of the other ones I found. This is what it looks like in person, so to speak. And then I've mounted it. There's the rear part of it, as you can see here. It's Brunner. It's in a little tray like that. That is synced with the rudders. And let's see if I can get that back. Yeah. So these are the rudders. And they also have motors in them, and they give you the kind of force you need when you're doing a turn as far as the yaw is concerned, or you're taxiing and so forth. And this is what it looks like when it's actually installed. Okay, so this one, this is a little video. And that's you either do that, or the other choice would be to have discrete instruments and have sensors, potentiometers on each one, and so forth. But the advantage of this is, great advantage, you can make say 10, 20 different airplanes with different layouts, and you can control all of them with this one system. So I thought that was a good trade-off. Now, motion and perception. So the little short sidetrack here. To understand how to best manipulate the feeling of motion, you have to understand a little bit about the physiology of how that happens. Now, this is a picture of it's called a semicircular canals, or vestibular apparatus. It's your inner ear, and it's what causes you, if you get dizzy or balance or something. And each of these, interestingly enough, each of these little canals, there's 3 of them on each side, they have sensors in them that sense acceleration. So whenever you move your head in any direction, these little sensors are firing off into the 8th cranial nerve, into the brain, and it gets integrated with your vision. So if you try now, for instance, look at any spot, anywhere you want to look at something that's here. Look at a spot. So if you look at a spot, and you move your head up and down, left and right, except my spot's moving, but here, look at this spot. Left and right, up and down, you can see it doesn't move. It doesn't appear to move, right? You're moving your head. So that means when you're looking at a spot, if you move your head to the left, your eyes have to go to the right. If you move your head to the right, your eyes go to the left, and so forth. So up and down, any motion you have, your eyes track that spot. And it does that because the information sent by this system and integrated into the brain for sight matches those up and allows that to happen. So if you are in particularly a VR and so forth, where there's a disconnect, where what you see is not what your semicircular canals are telling you, that's how you get sick, that's how you get dizzy. And why tolerance for virtual reality has to be built up, because a lot of people can't tolerate that long. In comparison to a full, actual cockpit, whether it's real or something like this, you don't have that mismatch because you're in an actual environment where things that you're looking at don't move. What we take advantage of with the motion is an acceleration. So you probably have all had experience in a car wash where you're in the car wash, you're stopped, and the brush and machineries go by, and you're not sure if you're moving or it's moving. Same thing as if you're in, like in traffic and someone moves, you don't know if you're moving or not, put your foot on the brake. Anyway, that's again because of this mismatch of your head is telling you, I'm not moving, but your eyes are telling you, maybe I am moving. And so that gives you that feeling of motion, even though it's not real. So the point of all that was, let me get to the next one. Oh, we get. What I wanted to do with that is that on the motion system on this allows for 20 degrees of both pitch and roll and yaw. And so what we're doing on that is we are going at a rate of about maybe 1.5 seconds per 20 degrees, which is a reasonably good turn, not acrobatics, but it's, somewhat realistic. And so you can only sense acceleration. You can't really sense motion. All the semicircular canal stuff, well, it tells you you're accelerating, but once you stop accelerating and you're in motion, then it's not giving you that information. The way you think you're still in motion is your visual. So if you're flying the airplane, if you feel the first acceleration of the first 20 degrees or less than that, 15 degrees, you feel the acceleration, you think you're moving, you see the vision, it matches, so that works. And then if you slowly go back, the cockpit actually goes back to 0 again, but slowly enough where it doesn't accelerate, and therefore you don't know that. And then it accelerates again. In effect, you can trick the brain into thinking you really have a 40-degree bank instead of a 20-degree bank. Now, you can't duplicate, obviously, G-forces and feeling in your seat unless you're in a centrifugal system or whatever. So that's really kind of impossible for this kind of thing. But it's a way of, manipulating the perception to make it feel, if you add all those other senses together, that it's really happening. Software-wise, we basically used X-Plane. It has the best physics, I thought, for outputting information about the flight you're taking. The position in space at any one time, the acceleration, all that kind of thing. And so that's very much usable for all the devices and controls and everything that we're doing. It seemed to be the best software when I developed this. Hold on. Well, anyway, in conclusion, and this was just an example of what I went to do. I initially did this as sort of a challenge to myself and as a hobby, and it got really intense. And then by the time I got through with it and I could experience these things instead of being theoretical, I thought it might really have some commercial value at some point. So I basically was here just to get some feedback from everybody to get an idea of what they thought. And here's the finished copy. This is Van Nuys Airport. There's the tower there. And this is pretty much what I've got at this point. And it works very well. And unfortunately, I couldn't bring the whole thing here this time because of some logistical issues. but maybe next time. But so I can't bring you the experience by words, but I can just say that if you think about flying a real-life airplane and you think about all these senses, all your sensory responses to all the stimulus that you're getting, that's what this addresses in all those different levels. And this is the finished version when I assemble the whole thing. Right now I have this part available, and I'm still working on the motion part. The challenge for me on the motion was that I had to get a motion system that could support 1,200 pounds of load and the acceleration of that. If you think of a 1,200 pound, well, this weighs about 700 pounds. So you have 700 pounds moving at 20 degrees in 1.5 seconds. There's a lot of forces involved in terms of angular momentum and all the kind of physical things that they deal with. So you had to make a system that was very robust and very strong. So we modeled it, we tested it, used load cells to test the actual failure point of all the fasteners and all the systems. So that's a big project. So I expect to have this fully working maybe in the second quarter of next year. So that's where I'm at with that, and that's where you open the door, go in, close the door, and that's how you get a complete experience with no distractions and all the rest of it. And all you're getting is all that various physical inputs that you put a little bit of it, to stitch a little bit of it together in your mind to form a real feeling, so that you really kind of forget that you're in a simulator at that point. And that's it. Thank you.
Thank you very much, Steve. We do have time for a couple questions, so if you just raise your hand, I'll be coming down the aisle with the microphone so you can ask it.
And if there are other questions, I can be right outside here for additional questions to answer.
Okay, so you said 20 degrees in 1.5 seconds. Let's see, mathematically, that's about 13 degrees a second. Would be your roll rate, somewhere in that vicinity.
Yeah, I'm between 1.5 and 2 seconds, depending upon what all the other positions are doing. But that's close.
So physiologically, if you wanted to simulate like a high roll rate in a fighter, like 120 degrees per second, how would you go about doing? If you could do that, how would you go about doing that?
Well, the problem, this was again intended for a general aviation, non-acrobatic kind of thing. How would I do it if outside of this system? The only way I can think of, well, one, if you want to have that G-force, you'd have to have some kind of centrifugal. The simulator you're in would have to have some centrifugal force, which they do have, and there's also some that have. They have like a gymnasium thing, and they have cords attached, like bungee cords, and they can whip you around and feel that kind of turning, and then you have to have. So I don't know. I really couldn't use this system for that, because the forces involved in terms of angular momentum and what that would do to the connection between the motion and the cockpit would be greater than I could probably get material to have. Obviously, in a real fighter, it's in the air and it's got different forces, but I don't think I could apply it to that portion to what you're talking about. It would have to be a very more mild kind of thing. You couldn't really simulate that. Anybody else?
Could you provide any information on the type of motors and servos and that sort of thing that you're attempting to use for the motion?
I could tell you some general things. Since I had to have this in a bedroom situation, I couldn't have more than 15 inches from the ground to the bottom of the simulator. And there wasn't any linear actuators, and I tried all kinds of things, searched internationally, couldn't find anything that specs, and then also have that kind of load. So I ended up designing my own system, which is different than anything I can find. So I can't tell you exact specifics because of patent issues, but I can tell you that there's 3 motors. They're hybrid stepper motors. They have approximately 15 Newton meters of torque. I use 10 to 20, ratio of 10 to 20 gear reduction system that attach to that motor in order to get the kind of torque I need to control this. It just is not, the way I'm applying it and how I'm moving it is unique, and probably next year I can disclose that, but that's as much as I can probably tell you about it.
All right, thank you very much. As Steve said, he'll be right outside to answer any more questions that you
outside.
might have.
Thank you. Thank you.